एक होगी कैमरा कंट्रोल होगी
Let's start again. Okay.
Okay, we'll continue. There was some technical issue. We'll continue. So, this method, the method of substitution, is applicable for the problems in the following types. What do you notice in these problems? Function is there, derivative is there. Function is there, all these problems. Wherever you see a problem, where the function and derivative coexist, for such problems, you can use this method. I'll take one simple example. Integrate sin to the power of 5x into cos x dx. Method is put sin x equals t. See, if you put sin x as t, you will get cos x. But if you put cos x as t, you will get sin x, but power is there. That's why you should take f of x, the power function should be taken as f of x. Now what happens is, cos x dx is going to be dt. So this expression will be dt. So this becomes t to the power of nt. The problem was not in the standard form. When we observe the problem, we notice that it is of type f of x into f dash of x. So I take sin x as t, cos x dx is dt. Now this is the standard formula. We can use that. T to the power of n plus 1 by n plus 1 plus c. What is note number 1? After completing the problem, replace substitution. What is t? T is sin to the power of n plus 1x by n plus c. I'll just work on our two problems just to give you this how this method works. Then we'll go for all different types because there's no point in working all the problems with exercise. We have a limited time. But we will be working all types of problems when we start the examination papers. So let me take another one or two problems of this type. Let us say you are given x over x square plus 1. This is a problem given. So whenever a function has got both numerator and denominator, usually you take denominator as t. Repeat, function has got both numerator and denominator, both are functions. Invariably we choose denominator as t. The exception is when the function is inverse function or logarithmic function. Because when I differentiate an inverse function, for example, I differentiate sin inverse x, I get 1 over root of 1 minus x square. The derivative goes to denominator in case of inverse function. Similarly, in case of logarithmic function, if I differentiate log x, I get 1 by x. Except those two, whenever a problem is given, you take denominator as t. So put x squared plus 1 equals t. Let us differentiate this. I get 2x dx equals dt. But I have got x here. So what is x dx? It is half dt. So half is a constant, I keep it outside. Dt over t. Because x squared plus 1 we have called it as t. So now it is a standard integral, which is nothing but log t plus c. That is half log. What is t? X squared plus 1. Just work another 2-3 problems just to give an idea. Let us take secant square x to tan x dx. So, which one I should call it as t? We can call tan x as t. So, if I call tan x as t, put tan x equals t. You get secant square x dx equals t. So, this one. So, there secant square x dx is dt, tan x is t, you get t dt, that is t square by 2 plus c. What is t? Tan square x by 2 plus c. We'll take one more similar problem just to explain how the problem works. Supposing you are given secant cube x tan x. When they give secant square x tan x, we took tan x as t. We got secant square x and differentiation. We could remove all dx and bring in all x and bring in dt. Now here, if I take tan x as t, I get secant square x, but they have given secant cube x. So this is a very tricky problem. Write this as secant square x. This is secant square x into secant x tan x dx. So arrange the problem. These adjustments are required in integration. This is what you should understand. How to arrange the given problem. Now put secant x as t is equal to t. So secant x tan x dx equals dt. So this entire expression will be replaced by dt. So the previous problem was secant square x tan x. We call tan x as t here. They have given secant cube x. So what is the problem now? Secant x is t, therefore this is t square dt. You get t cube by 3 plus c. That is equal to what is t? T is secant x. Secant cube x by 3. Let me take one more problem. Secant square x over a plus b tan x. I told you whenever you have numerator denominator, put denominator as t. Exception is inverse and logarithmic. So here we shall put a plus b tan x equals t. So a is a constant, derivative of a is 0, b is a constant, keep it as it is, tan x is secant square x, so b secant square x dx equals t. So what is secant square x dx? It is 1 by b dt. So the problem is going to be 1 by b outside dt by t. That is a standard integral log t plus c 1 by b into what is t? A plus b tan x. I'll just work one more so that you understand how the problem progresses. So the first thing you should remember is to see whether and differentiating one of them, you need the other one. For example, differentiating tan x, I get secant square x. Supposing they are given secant cube x, we can't work this problem. So, supposing you are not able to work the problem by substitution method, then we think of some other methods. So, let us take one more problem. Sin square x over 1 plus cos square x. So, it has got numerator and denominator. So, it's not an inverse function or logarithm function. So, we should take this 1 plus cos square x itself as t. But when I take cos square x, differentiation of cos square x is minus 2 sin x cos x. But we have got only sin square x. The problem is not sin square x, it is sin 2x. It is sin 2x. So what is that? You put 1 plus cos square x as t minus 2 sin x cos x dx is dt. But you know that 2 sin x cos x is sin 2x minus sin 2x dx is dt. The problem will be given in such a way that to differentiate one of them, you should get the other one. Supposing you don't get, then that problem is not a problem of substitution. We'll be taking up other types little later. 2x dx is minus dt. So again the problem is minus dt by t is minus log t plus c. And what is t in this problem? T is 1 plus cos square x minus of log of 1 plus cos square x plus. I'll just work one or two problems of definite integral also. Please note I am just working on the problems, minimum number of problems to get an idea of how to work a problem by substitution method. We'll be working more problems when we go for the examination tables. It's only just a bird's eye view of the problems, just an idea about the substitution method. Now, I'll work one or two of definite integral also. One or two of definite integral problems. 0 to 2 x plus 1 into root of x square plus 2x plus 3 dx. Now let us not look at 2 and 0. Let us think that it's an indefinite integral problem only. First we shall think like that only. So can we work this by substitution method? That is possible if you call one of them as t. Supposing I put x square plus 2x plus 3 equals t. Difference of x square is 2x and 2x is 2, dx is dt. You can take 2 common. 2 into x plus 1 dx is dt. So what is x plus 1 dx? It is half dt. Now what you should do is, I have given note number 2. Either you can replace the value or you can find the corresponding values of upper and lower limit. That's always a better method. So what you do is, let us take the limit. When x is equal to 0, what is t? X square is 0, 2x is 0, plus 3, so t is 3. When x is equal to 2, what is t? X square is 4, 2x is also 4, 3 is 3 only, this is 11. So whenever we work a problem of definite integrals by the method of substitution, remember to change the limits. So 0 to 2 becomes 3 to 11. You have got half outside, it's a constant. You get t to the power of half dt. Because x plus 1 dx is half, I put it outside. The entire expression we have called it as t to the power of half. What is the integration of t to the power of half? T to the power of half plus 1 by half plus 1. Between the limit 3 to 11. See, half plus 1 is 3 by 2. So this will be half 1 over 3 by 2. 2 will come up. Therefore 2 and 2 will cancel. I will keep 1 by 3 outside. t to the power of 3 by 2. Between the limits 3 to 11. See, this is 3 by 2. 2 will come up, 2 or 2 will cancel. 1 by 3 remains. Half plus 1 is 3 by 2. Now substitute the limit. 1 by 3. 11 to the power of 3 by 2 minus 3 to the power of 3. Let me work one more problem of definite integrals. Integral 4 to 8 x over root of x square plus 5 dx. So, I told you earlier, whenever numerator and denominators are there, invariably you have to call denominator as p. Put x square plus 5 equals x dx equals half dt. I have skipped one term here. I know I get 2 and I don't require 2 here. Therefore, I am shifting it there. Because it's a problem of definite integrals, we have to change the limit. When x is equal to 4, t is equal to 16 plus 5, that is 21. When x is equal to 8, t is equal to 64 plus 5, that is 69. So what do you get? This is half outside. You have got dt and this is t to the power of minus half dt. T to the power of minus half. Now, because it is a denominator, I have to take numerator. What is the integration of t to the power of minus half? T to the power of minus half plus 1 by minus half plus 1 between the limit. This is 4 to 21 to 69. 21 to 69. These two will cancel because minus half plus 1 is plus half, that will cancel. So you get t to the power of half, that is root t, from 21 to 69. Now, you will learn to simplify this. This is root 69 minus root 21. Leave it like can't be simplified. It's not possible to simplify all the problems, but simplify to the extent possible. Let us work one more problem. 0 to 2 x square plus 1 y 4x square 4x cube plus 12x plus 1 dx. Supposing I call this as t, I get 12x square plus 12. But take 12 common, I am going to get x square plus 1. So I will put the problems will be in such a way they give it. So it will be possible to work by substitution method. Suppose it doesn't work out, then we have got to change the method. So this is 12x square plus 12 to dx equals dt, or x square plus 1 into dx is equal to 1 by 12 dt. Change the limit. When x is equal to 0, t is equal to 0 plus 0 plus 1, that is 1. When x is equal to 2, So 2 cube is 8, 8 4s are 32, plus 24, plus 1, 57. So the limit from 1 to 57, 1 by 12 outside, this is dt by t, that is 1 by 12, dt by t is log t, 57, sorry, 1 to 57. So 1 by 12 log 57 minus log 1. Log 1 is 0. So you can write it as 1 by 12 log 57. That's the answer. Let me work one problem of definite integral involving trigonometric function. Today we lost about 15 more, around 20 minutes because of internet problem. Integral 0 to pi by 2. Secant x, sorry, sin x into cos cube x dx. So the power is on cos, so put cos x equals to. What is difference with cos x? Minus sin x. I am shifting that minus sign directly and saving one step. Definite integral, we are declaring the limit. When x is equal to 0, t is equal to cos 0, that is 1. When x is equal to pi by 2, t is equal to cos pi by 2, that is 0. The problem is minus sign is there outside. 1 to 0 t cube dt. That is 1 by 4 t to the power of 4, 1 to 0. That is equal to minus 1 by 4. So 0 minus 1, because upper limit is 0. First we should put the upper limit, then lower limit. The answer is 1 by 4. L1, one more problem. Integral 0 to pi by 4. Three minus 2 cos square x whole cube into sin 2x dx. So we have to check whether it is possible by substitution method by putting this as t. So put 3 minus 2 cos square x is equal to t. Derivative of 3 is 0, 2 is a constant. Cos square x is minus 2 sin x cos x. Therefore, it becomes minus 4 sin x cos x dx equals 0. So I write this as minus 2 sin 2x dx. Know why? How? Because we know sin 2x is 2 sin x cos x and sin 2x is given here. So what is sin 2x dx? It is half dt, minus half dt. The problem is going to be, you should take the limits also. When x is equal to 0, t is equal to 3 minus 2 into cos square pi by 4. Cos pi by 4 is 1 by root. So cos square is equal to 1 by root. That is equal to 3 minus 1 by root. See, cos pi by 4 equals 1 by root 2. So if you have got cos square 1 by 2 root 2 whole square, that is 1 by 2. when t is equal to pi by 4. When x is equal to 0, t is equal to 3 minus cos 0 is 1, 3 minus 2 that is equal to 1. So what is the problem now? The upper limit is 2, the lower limit is 1. So 1 to 2, you have got minus half outside, keep it outside. Then you have got t cube dt. So what will happen? T cube is t to the power of 4. So it becomes 1 by 8. T to the power of 4, 1 to 2. That is 1 by 8, 2 to the power of 4, minus 1 to the power of 4. Minus sign is there. It is minus 15 by 8. Because 2 to the power of 4 is 16. We will work one more problem of substitution method, where the problems are like f of g of x into g dash x. This same problem I will be working one or two. So let us take one problem. Sin root x by root x dx. Here I cannot call sin root x as t because there is no cos term. So what we do is put root x equals t. So you should realize this is a problem of the type f of g of x and g dash. So what is f? That is sin. G of x is root x. For the g dash of x, 1 over 2 root x. So when you differentiate this, you get 1 over 2 root x dx, that is equal to dt, or 1 over root x dx is 2 dt. So this is 2 sin t dt. Integration sin t is minus cos t. Minus 2 cos t plus c. Minus 2 cos, what is t? Root x plus. So we work problems of the type, remaining types, where fx was there, f dash of x was there, either in numerator, together denominator, whatever it is. But this time we have not worked, so I just work one more of this type. Cos x over 16 plus sin square x dx. Here, if I take 16 plus sin square x dx, I'm going to get sin 2x. Sin 2x is not there in numerator, we got only cos x. So you should realize on differentiation I should get cos x. Therefore, I must choose sin x as t. So put sin x equals t. You cannot take cos x as t because I told you whenever you have both numerator and denominator, denominator should be taken as t. But if I take 16 plus sin square x as t, I will not be getting cos x. So I have only cos x. Therefore, other alternatives I will take sin x as t. Then let us see how the problem works out. Differentiation of sin x is cos x dx. This is dt. So what will happen? dt over, I got 16 write it as 4 square and I got p square. So by substitution method, we have reduced the problem to the standard type. So what is the integral you have got to use? Dx over a square plus x square. That is 1 by 2a, sorry, 1 by a tan inverse x y. You should remember that formula. So what is a in this case? 4. 1 by 4 tan inverse p by 4 plus c. After the problem is over, you should replace p 1 by 4 tan inverse of what is t? Sin x by 4. We'll take one more problem. Integral of dx over x into root of 1 minus log x whole square. So if I take 1 minus log x whole square as t, I will not get 1 by x. So what is that? I should take log x as t. These things you learn when you got more problems. The moment you look at the problem, you get an idea which should be taken as t. The beginning confusions will be there. So the confusions becomes very clear. That means you come out with a conclusion. The confusions once you work many problems. There is no other method. Only thing is you have got to work more problems. Put log x equals c. 1 by x dx equals dt. What happens? dt over root of 1 minus d square. What is this? Let me recall dx over root of 1 minus x square is sin inverse x. So this is sin inverse t plus c. What is sin inverse? What is t? Log x plus c. We got one problem of definite integrals by this method. This one. Zero to one. No, it is not 0 to 1. It is 0 to 1 only, take no problem. 0 to 1. Dx over 25 plus 4x minus 3 whole square. No, you should get only dx on differentiation, there is no other function. So what you should do is put 4x minus 3 as t. You get dx is equal to 1 by 4 dt. When x is equal to 0, t is equal to 0 minus 3, that is minus 3. When x is equal to 1, t is equal to 4 minus 3. So what happens is, the upper limit is 1, lower limit is minus 3. Minus 3 to 1. dt over, you can write 25 as pi square plus d square. But dx is 1 by 4, keep the 1 by 4 outside. Now, this again same thing. The formula you need to use is dx over a square plus x square, that is 1 by a tan inverse x by a. If you are not able to recall or recognize the formula, there is no other method, therefore you need to remember all the formulas. So 1 by a is 5, 1 by 4 is there. 1 by 20 tan inverse of t by 5 plus c. There is no c because definite integral problem. We put the limit minus 3 to 1. So 1 by 20 tan inverse of 1 by 5, upper limit is 1, minus tan inverse of minus b by 5. That's the final answer. You will not simplify. Of course, you can use the formula tan inverse x plus tan inverse y and all that. That is not required. Now, I would like to teach you one more. What about 10-15 minutes? I just want to teach you one more formula that is required for working some of the problems, and you can add that to the list of formulas. One extra formula I am going to teach you. You take y is equal to 4x plus 5, or rather ax plus b to the power of n plus 1 for a into n plus 1. I am adding one more formula to the list of integration formulas. You just take this function. You have to find dy by dx. You know a into 1 plus n plus 1 is a constant, keep it outside. When you are differentiating ku, keep k outside, differentiate this. Which rule? Chain rule. N plus 1 into ax plus b to the power of n plus 1 minus 1 into a. See, I have differentiated power first. N plus 1 to the power of n plus 1 minus 1. Then I have differentiated ax plus b. A is a constant, x is 1.